So in this problem, let's assume that the separation between the first maximas and on the either side of the central maxima is x. So we have a screen and then we have a source. Let's say this is the first maxima on the upper side, and then this is the second maxima. This is the first maxima on the lower side. Then if the distance between them is x, so then this becomes theta equal to lambda by a, and we know that this distance is 2 meters. Okay, from this figure I can write tan theta is equal to x by 2. This is actually half, so we get x by 2 into 2, which is nothing but x by 4. When theta is very small, we can approximate tan theta into theta. So this gives us theta as approximately equal to x by 4. And we know that theta is equal to lambda by a. So we know that theta is equal to lambda by a, so we get lambda by a is equal to x by 4, and this implies x is equal to 4 lambda by a. So we substitute all the values in this and we get x is equal to 4 into the wavelength of light, which is 600 nanometers. So we have 10 power minus 9 divided by 10 power minus 3. So we finally get x as 2.4 millimeters. This is the answer.